just to give everyone a quick introduction of Kevin Brock again. So this is his second energy training he's doing with us. And if you didn't join us for the first, we've been a long time, we've had a good collegial relationship with Kevin for many years. His work with Duke Power and their incentive programs and contractors of that. And he's been teaching classes at Lenore Ryan in their sustainability program, and just has a lot of super experiences as an engineer in the energy field to share with us. So we're really excited for his presentation today on financial analysis, and we hope that we can have a really nice dialogue with everyone. And we welcome Elaine joining us.
We're fog is dense in my area. All back up.
Oh, well, good. Well, we're just getting started here. So, you know, our financial analysis is pretty simple in our program, the way we show things. So maybe we're going to learn some things today on better ways to communicate with the client, better ways to really help sell our energy ideas and projects to a wide variety of clients that we're speaking with, and you know, maybe there'll be some things that we can adapt in the future or learn better ways to present information. So, so with that, I'll turn it over to Kevin.
Well, thanks, Terry, and thanks again, all of you out there, and Elaine here in the room. We're gonna talk about the way we communicate the financial metrics of investments. And I like to think of these energy conservation measures that we recommend as investments for a business like any other investment a business might make in production equipment, in new buildings or warehouse or whatever else a business might invest in. And we're going to look at this through the lens of a more sophisticated CFO who in the end is often one of the primary decision makers in whether the business might make an investment. So this information I'm bringing you is based in large part on things I learned fairly late in my career. I was working for Duke Energy through DNV as a contractor, and we were able to take advantage of some training by a guy named Mark Jewell, who has built a reputation as a trainer and consultant in selling energy conservation measure investments. So we're going to talk, a lot of what I talk about is based on what he's done. So we're going to talk about simple payback period, what that means, and what might be some of the limitations of that particular metric. We're going to talk about net present value, and we're going to talk about why that might be a better financial metric that might be difficult for some clients to understand who may not have as sophisticated a background in financial metrics. We'll talk about internal rate of return. We'll talk about the savings to investment ratio. And we'll talk about the concept of equivalent revenue, which is something I had never thought about before. But it's an important metric for a business that is in the business of making money. So we'll talk a little bit about that. And then I'm going to introduce you to an Excel calculation tool. I've shared that file with Russ and Terry, and hopefully he they will share that with the rest of the team, and we're going to actually walk through an example using that based on an example of a project that Russ provided to me with some cost estimates and energy saving estimates, and a way to use those estimates to calculate these metrics and what they mean. So that's our agenda this morning. And as usual, if you have questions, you can interrupt at any time, or you can put something in the chat. I think Terry is monitoring that, and we're glad to help us all learn together, because none of us is as smart as all of us are. So let's move into simple payback period. Why is it popular? Well, it's easy to understand. The basic formula for simple payback period is let me make sure I get it right. It's the total investment or total cost of a project divided by the first year annual energy savings. Okay? And typically that's going to be, unless it's a really good project, it's going to be greater than 1. And in most cases, it's going to be greater than 5 years, or even greater than 10 years. As an example, several years ago, at our home in Waynesville, which is now Net Zero Energy, by the way, my wife and I decided to install a photovoltaic system on the roof. Our home was already very energy efficient with a HERS rating of 43, which is pretty doggone good. And by installing these solar panels, we made our home net zero energy. The contractor who installed the system did a number of financial calculations to help us make that decision. And it turned out that, taking into account the rebate from Duke Energy at that time, plus the 30% federal tax credit at that time, when we deducted those savings from the initial cost, we had an out-of-pocket cost of X amount of dollars. And then they calculated energy savings, and the simple payback period was over 10 years. Mm-hmm. Okay? So that's not bad. But it also points to the limitations of simple payback period. Number one, the simple payback period doesn't take into account the time value of money. So we're looking at the first year energy savings, but over time, in present dollars, energy savings get better. So that's a real problem with that metric, is it doesn't look beyond even the first year, let alone what happens at the end of that payback period. So if my simple payback period is 10 years, I'm still saving money in year 11 and 12 and beyond, out to the end of the life of that investment. So whatever that life is. So that's a limitation of that metric. And it can also, I think, establish unrealistic expectations, or it can, because it's misunderstood by many people, they have unrealistic expectations. And by that, I mean simply this. If I make an investment and then I can recoup the value of the investment over 10 years, in simple terms, that's a 10% rate of return, right? So I get a tenth of the money back every year. Plus, I have the value of that asset, which is mine. I could put my investment in the bank, and as Terry and I were talking before we started, I could go to the banker and I say, I want 10% on my money. And then we would wait to see how long it takes for the banker to stop laughing. So, because we all know what the return is on any kind of deposit, whatever you want to consider. It's not going to be 10%. So those are some of the issues or limitations that I have with simple payback period. And I'm not a finance guy. I didn't study accounting in college. Had a little bit of what was called engineering economics, but I do know enough to understand these limitations of the simple payback period. And not to say that's not a useful tool to use in communicating with clients, but it's, I think, important to be able to share those limitations if that unrealistic expectation is a barrier to proceeding with the project or a barrier to making that investment. So that's where we're going with these limitations. And it's also, I think, useful to remember that sometimes these unrealistic expectations, for whatever reasons, apply to energy conservation measure investments in particular when they don't apply in other investments the business might make. So I think it's useful just to understand that mindset as well. It's so ingrained, I think, in, I don't know, popular culture or wherever, that an investment in energy conservation should have a 3-year payback. You know, I heard that a lot when I was talking to small business owners in the Duke rebate program. And so how you communicate around that mindset, I think, is very important. So that's why I wanted to share these challenges and limitations with simple payback period. Not that you need to change anything you're doing to do the financial evaluations, but simply how you communicate that with your clients, I think, can make a difference in their decisions to move forward with an investment. We might just ask for any questions about that.
Anybody have any questions? Anybody have any comments on that? Or
observations or whatever?
You know, Kevin just said, 3-year when you're in a small business. A lot of our school systems, they kind of have a 5-year rate. You know, they know they're going to be around.
Yeah.
But they literally have a hurdle, and they say 5 years, and we'll put it into the capital planning budget. And if there's money, we'll do it. But so that's kind of atypical. On the manufacturing front, sometimes we get down to 18 months or something crazy, depending on how tight dollars are, and it's almost like the mindset's very different from longer term investment.
Well, but on the other hand, when you're dealing with a school district, for example, the challenge then becomes the election cycle. And so it's a challenge for politicians who are standing for election in 2 years to look beyond that election cycle too. So all these things come into play, and it's a fascinating dynamic that probably deserves a lot more rigorous study than my opinion.
Also, in that time value money bullet, current conditions, we have to take into account inflation, and that same installation is going to cost us much more.
That's another factor, and we'll talk about that, the opportunity cost and how inflation affects the opportunity cost. Some economists who have argued for the years that the Fed's 2% inflation target might be too low to encourage investment. So companies will be with lower inflation. Companies might become more conservative in terms of making investment because they can wait without much of a penalty. So anyway,
sorry, we have a little feedback. If y'all can keep yourself muted while you're, if you're not speaking.
Okay, so we're going to move on from simple payback, and we're going to talk about net present value. What is net present value? Net present value is the difference between the future value of cash outflows and the future value of cash inflow over a fixed period of time. Okay? Typically, in my experience, I have seen net present value calculations over a term of 10 years. Some businesses might choose to do a net present value calculation over a lesser term, maybe 7 years. But in my experience, it's typically 10 years. What we mean by present value are the future cash flows expressed in present dollar values. So that accounts for inflation. And we throw another thing in there called the discount rate. And I was talking to Terry earlier. A discount rate is one of those terms that's kind of hard to define, like entropy is for us mechanical engineers who studied thermodynamics back in the day. But we'll talk a minute about discount rate. But the advantage of net present value is that you're looking at long term of the investment.
Right. You can keep going. Sorry.
And we're also taking into account we're also looking at all the cash flows. For example, if you're doing a lighting project, like in the example Russ sent to me, replacing T8 or T5 fluorescents with LED lighting, one of the major cash flow effects is a change in the maintenance cost, simply because of the difference in the life of the bulbs, okay? You have to relamp less frequently. And so there are savings to be realized. You might consider other financial advantages. For example, there are studies, I know there was one study in particular several years ago out of Brazil where someone studied productivity in a manufacturing facility against the improved quality of lighting, whether that lighting quality was an improvement in the color corrected temperature or the color rendering index and the light level. They looked at those things and then measured changes in productivity, and they came up with a 3, 4, 5% increase in productivity based on improved lighting. So you can attempt to quantify that in this financial analysis. That might be a non-financial benefit. We talked about schools. There are several studies that relate student performance to the quality of lighting. So now that's
right.
not a number you can plug into net present value analysis, but it is a non-financial benefit that you can help a client consider. So those are the advantages, in my opinion. What are the challenges? Well, the big challenge is estimating costs, and we all struggle with that. Particularly if you're looking at future cash flows, looking at a little more nebulous thing like relamping. Okay, you can look at numbers and say the numbers say the lamp life is this and so forth, but that's not an exact science, and neither is the cost of that relamping. Do you do the relamping as a mass relamping of the entire facility at one time? Do you do that as lamps burn out over time, one by one? And there are differences in costs in doing that. So those are challenges that you really do have to consider when you're doing the analysis. Okay. But they're important to consider. So there are these terms we talk about, net present value, the discount rate. The discount rate is defined as the minimum return you would accept of an investment. Okay? Some people would say that might be equivalent to the minimum return you would want if you decided to put that money in the stock market. Okay? That might be a way to look at discount rate. Some would look at it as sort of a fudge factor or safety factor. Okay? What it does, imposing this discount rate sort of puts a little penalty on those future cash inflows, okay? So that you can say, if I come out with a net present value greater than 0, that's really going to be, I've got a 10% fudge factor dialed in, so it's actually going to be better than that, okay? That's one way to look at discount rate. And I use 10%. Typically, that's the number that we used in the Duke program when we were talking about this kind of analysis. And it's pretty typical among CFOs who are evaluating investments across the board for their company, is to say, we're going to crank in a 10% discount rate in our calculation. So that's what it means, and that's why I say it's a lot like talking about entropy. It's kind of vague, kind of hard to explain, but that's the number that most people use is 10%. We talked about the term of investment. Typically, we look at 10 years. In my experience, some might look at a shorter term, which changes the calculation. You're not looking at as many cash flows. And then this accounting for the cash flow, identifying them, estimating them, and putting them in the right place, in the right year, because the year in which they occur affects the present value, okay? So the spreadsheet that I have takes care of that. It accounts for those, the present value of those future cash flows. That's what we're trying to do. So we add up all the cash inflows as positive to us. We deduct all the cash outflows as negative to us. And that's where we get the net. And if the net is positive over the term of the investment, then at least that analysis suggests it's a good financial investment. So it would cross that threshold, and then there may be other considerations in the final decision to make that investment. Okay.
So question for Kevin. One, did you see very many of your clients over the years wanting to use net present values as their economic, justification?
Not very many in dealing with small business.
Okay.
Larger businesses, yes, that's what they do.
Okay.
As routine for all investments. But in small businesses, the body shop, the mom and pop restaurant, the boutique clothing store, on Haywood Street in Asheville. No, they don't think in those terms. They're the 3-year simple payback folks, typically. So then it's a different kind of selling technique to encourage them to make that investment. That's my experience in that.
Thank you.
Okay. Internal rate of return, the definition of internal rate of return is actually the discount rate that would result in a 0 net present value. Okay. That's a textbook definition. I know my spreadsheet calculates that, but it's sort of it sets the net present value to 0 and then goes back and calculates that interest rate. So, and typically, if that's less than your 10%, it's pretty good investment, I think. So it's just another number to use. But people talk about rate of return, but they are return on investment, same principle. They'll talk about it in terms of that first year. And they don't look at that, the present value of future cash flows, which is what we're looking at with net present value. Internal rate of return is that sort of that ROI if the net present value is zero. Savings to investment ratio. Okay, that is actually, it's a simple definition. It is the amount of first year savings divided by the amount of the investment. So it's the inverse of simple payback period. It's again, a lot of people will look at that and say, we want that to be higher rather than lower. Okay. If it's your savings to investment ratio is 0.1, that's a 10-year payback period. Right? But again, it has the same limitations as the simple payback period. Some people will do a sort of a modified savings to investment ratio using the ratio of the cash inflows, the ratio of the present value of the future cash inflows divided by the ratio of the present value of the future cash outflow. Well, I say future and present. So that's a little different terminology then when you're using those future values. But that's the basic definition of that. But that's calculated in the spreadsheet as well. Equivalent revenue. Here you go. This is a very interesting concept. This applies to for-profit businesses. It depends on a business's net margin. There's a financial definition for net margin. That's basically their percentage of it's the profit as a percentage of their revenue. It's very useful, and I'll tell you why in a minute. But first, you need to know what the net margin is. Fortunately, there's the internet. So, the Stern Business School at NYU does studies of this, and they publish the industry average net margin for a whole range of industries. Okay. The net margin for supermarkets is very low. The average of 1.25%. So when you go to Ingles, they really do make it on volume. They have to sell a lot of stuff to get a 1.25% profit. An apparel store, I looked this up on this website, an apparel store is about 7.5% net margin, okay? But they sell $100 worth of stuff, they get a profit of $7.50. It's useful. Why is it useful? Well, you take that first year savings from your investment, and then you divide that by the net margin. And that basically tells you how much increase in revenue the business has to have to realize that amount of the amount of that savings on their bottom line. So if you're running a supermarket like Ingles and you got a 1.5% margin, and you're gonna save them $50,000 with their lighting upgrade a year. Divide that 50,000 by 1.5%. I didn't bring my slide rule, but that's how much more groceries they would have to sell to realize that amount of profit.
$4 million.
Okay. They have to increase their sales by $4 million to see that much profit. That's pretty useful. Okay. Now in my spreadsheet, we're going to show you in a few minutes, we can plug in the net margin and it will show us that calculation. Just another number to have. Okay. Just another number to have in your toolkit as you talk to business owners particularly. So that's something I had never thought about until I went through this kind of training from Mark Jewell that we talked about earlier. You know, when we talk about these future cash flows, there's also other kinds of things that come into play. Say in commercial real estate, we're dealing with tenants and owners and who's responsible for paying for what, and it can get really, really complicated. That's a whole nother course that I'm honestly not qualified to talk much about, other than it's complicated. You get into, per square foot lease rates, and you get into all kinds of tax implications and so forth. So, but that again, that's another world. But this kind of information is very useful. Net margin, I think, is very useful when you're dealing with a client who might be reluctant even after you explain that 6-year payback he doesn't like, or he doesn't like, means 17% interest, right, or whatever that is, right? So this might be the next conversation. Oh, by the way, you'd have to do this much more body work. See that on your bottom line. Anyway, it's an interesting conversation. Okay. So I'm going to open up here in a minute. We figure out all the screen sharing stuff with GoToMeeting. This Excel calculation tool that I put together. We're going to put in some inputs. We're going to put in the first year investment. We can actually put in total cost and then deduct things like rebates and tax credits, okay? Or some of you may have come across the 179D tax deduction. in some of your work. Another interesting.
Which one is that one?
It's really for lighting projects, but it's also for other projects. But it's actually a tax deduction that's available to businesses, Section 179D of the tax code. I learned this because I did some work with a tax accountant. He dealt with this stuff. And it requires an engineering certification of the energy savings. You get up to, for a lighting project, you get up to $5 a square foot. 179D tax credit. So, something to look into as well for your clients. But maybe consult with a tax attorney too, so you understand what you're talking about. But you can account for those first year outlays and first year offsets like rebates, tax credit. Okay? You put in the discount rate that we talked about. I usually just do 10%. You put in the inflation rate. Okay, we can debate inflation rate. Right now, I would probably put 5 to looking at a 10-year. I would just say 5%. That's a couple of years ago you could put in 2.5 or 3%. 5% now over a 10-year investment. Again, that's something you've got to figure out exactly. You put in your first year energy savings, and the tool actually adjusts the future energy savings based on inflation. Okay.
Based on the
inflation rate that I put in. Because that assumes that utility costs, or the cost of electricity for a lighting project, is going to track with the rate of inflation. Not true, but because utility costs, as we know, change irregularly with the utilities and the utility commission. But we don't try to guess utility rates. We just simply put that first year savings, and we're using utility rates in that first year.
Right.
And then we'll adjust those based on the rate of inflation. Okay. And we'll put in these other cash flows that occur during the term of the investment. And if the client is financing the investment, we can also put in finance costs. And those would be, again, future cash flows. But then we convert all that to present dollars. Okay? All the future cash flows get converted back to present dollars. Okay? So let's see if we can do this, Gary.
Sure. So you're just going to go to
Here,
share. Yeah, your share screen right behind there. Sorry, that one. That one. Yep.
There's something else. All right. Now, it looks like that's working. All right. So, we're going to just sort of walk through how this works. This is blank right now, and if you click in some of the calculated things, well, if you look down here, you'll see the errors like division by 0, but don't have any numbers in it yet. We've got to populate it, okay? Also, down here on the right, we'll see a little graph that shows the annual net present value of the cash flow. so you can see how the cash flows change over time. Okay? That's just interesting to have. Okay? So we're going to start at the top. We said we're going to put in a 10% discount rate. We're not going to finance this. We're going to assume that this client's going to pay cash out of cash reserves. So we're not going to put in a finance rate. The reinvestment rate would be a number that you would use if the client were going to reinvest the savings in some other investment. We're not going to deal with that right now. Okay, we're just going to simplify this. So we're not going to deal with that. And then we put in the inflation rate, and we're going to say it's 5%. Okay. Now we got our cash flows. The date 0 is the initial cash outflow. Okay. So, and when we put this as a single investment, means it's paying all the time, all at once, and it's also going to be after the rebate. So we're not going to plug those in separately. We're just going to put this as a net cash outlay. And because it's an outlay, we have to enter it as a negative number. Okay? So we're saying in this one we're going to get the cost of this, and I rounded some numbers from the example that Russ gave me just to make it simple. The cost is $44,000, and the rebate's going to be $24,000. So we're going to have a net outlay of $20,000 minus 20,000. Okay. So those are our outflows in the first year. If we look here, our net present value of cash flow, that's a present dollar. 20,000 is present dollars. Okay. So our annual net present value is minus $20,000. All right. We haven't put anything in here yet, right? So now, so in the first year, we're going to have energy savings. And I've got the first year savings as $1,900. And that goes at the end of year 1. That's not on day 1. You realize that in the first year. But in the first year, that $1,900 is present dollars. Okay? That makes sense? And that's positive because that's coming into me, right? All right, look at that. You go across on line 21 there, you see it has adjusted the energy savings for inflation. That's pretty cool. Oh, and that's compound too. Okay. So by year 10, we're in terms of our cash outflow is $2,900. I mean, our savings is $2,900, whereas now it's only $1,900. So that's based on 7.5, or that's based on 5% inflation. All right, 5% per year. All right. So if we just want to look down here, we can see how that's affected the net present value of our cash flow. And right now we have a net present value. If you look here in this cell B36, our net present value is minus $5,800, $5,900. Okay. Our simple payback period is 10.5 years. okay? And our return on investment, that's rounded, but it's 10%. Right?
Where are you seeing the payback period?
That's SPP, simple payback period. Right here, that's 10.5 years, okay? Now, here's where I put in a business net profit margin of 7.5%. And then you can see the equivalent net revenue. That means in order to achieve those savings, the company would have to sell $25,000 worth.
Great. Russ has a question.
Yeah, Russ?
So this inflation rate, that doesn't have anything to do with increased in rate schedules from the utility, correct?
What I'm doing, Russ, is that in fact does, I am assuming that the utility rate schedule will track with the rate of inflation. That's an assumption I'm making.
Okay.
So if you see on line 21, if you can see that on your screen, the energy savings.
Yep.
Those increase every year as the utility rates increase with the rate of inflation. That makes sense?
Yep.
Okay. All right. Let's just make sure we're all on the same page with that. Okay. Now, we're gonna also throw into this some maintenance savings. Now, even with T5 or T8, we would likely not relamp every year. Okay. But I'm going to say that in year 2, if I had T5 or T8, I would have to relamp. But with LED, I don't have to. And I just guess to relamp, I used a little higher number than you did in that than in the analysis Russ sent me. I'm going to say it's $5,000 to relamp the facility. So I'm going to put in maintenance savings here in year 2 of $5,000.
And you're assuming there that they're relamping all fixtures at once, and not
That whatever method they use, I'm saying this is what's going to cost. Okay, to relamp. And I would assume relamp the entire facility in year 2 if you had T5 or T8. Okay. And I'm going to say that you're going to have to do that again in year 4. And I'm not going to adjust this for inflation. You could do that, but I'm not going to. So there's another $5,000. Okay. In year 6, I'm going to say you're going to have to relamp the LEDs. So I'm going to say that's going to wash. Okay. Because in year 6, you would have had to relamp the others too. So I'm going to just to make this a simple analysis, I'm going to say that's going to wash. But I'm going to go out to year 8. I got year 4. Year 6, I don't do anything. In year 8, I'm going to put 5,000. And again in year 10. So I'm doing a 10-year analysis. So in year 10, I've got to relamp. I would have to relamp again. So that's another 5,000. And these are my assumptions. Your mileage may vary, as it says on the sticker, right? Okay. So we got that. You can see all these inflows here on row 24. And then you can see the annual cash flow on row 26. And then on 28 and 29, you see the present value of the outflows and inflows. So it's taking the actual numbers and converting them to present dollars. And so then you get the annual present value, the annual net, each year of those present values on row 31. And then in row 34, we have the net present value for each year, okay? So that's simply this number plus this number to get that number, plus that number to get that number, okay? See where my cursor's moving? So you can see the net present value get better each year to where in year 7 or 8 it gets to 0. And then in year 10, your net present value is almost $6,000. Okay. So on our graph, we can see the net present value go positive, which based strictly on this analysis would indicate that this is a good financial investment. Okay. But we also have the other numbers here. We have the simple payback period, still 10.5 years. That doesn't change. The return investment is 1/10.5. I've rounded it in this spreadsheet to 10%. Right, it's a little less than 10%. Savings to investment ratio hasn't changed. And then the equivalent net revenue hasn't changed, because that's just based on first year energy savings contribution to profit. Okay? So that's the tool. And you can click through there as you play with this and see the formulas and how everything calculates. Okay? I didn't get real fancy with trying to do different colors for what's calculated values and stuff. I'm not that good at Excel, so.
Hey, Kevin.
Yeah.
Bruce here. SIR, is that the savings investment ratio?
Right.
Line
That's
41.
the savings.
Yeah, is that
Yeah.
savings investment ratio?
Yeah. That is the, see, it says the sum of C29
Mm-hmm.
to L29. So that's all the savings
Mm-hmm.
over the 10-year period. Actually, the way I've calculated it here, divided by B18, which is the outflow.
20. Okay,
Yeah.
gotcha.
So it's the sum, yeah, the sum of the present value of the inflows divided by the outflows.
Gotcha.
Okay.
And is there a certain ratio we want to see there, or is that just a calculated figure depending on the other
It's just
inputs?
a calculated figure.
Mhm.
You can make of that, well, you can make of any of this whatever you want, but the savings in this, the savings is greater than the cash outflow. That's basically what it's telling you.
Okay, gotcha.
Yeah. And that's actually over the 10-year period, the savings in present dollars greater than the outflows in present dollars. Okay.
And those, elements that, for which, such as maintenance, for which you didn't initially, include an inflation rate, that's, when those are aggregated,
That improves, yeah, that improves the numbers. What happens, you know, if you're saving 5,000 in year 2 from relamping, you're going to save more in year 4. So yeah. But just as, you know, you can plug the numbers in or plug formulas in to calculate that specifically. But this actually would be a more conservative estimate if you did not inflate those numbers, right, over time. If that makes sense. More conservative meaning tending toward not making the investment.
Right. Question?
Anybody?
Yeah.
I mean,
Who has questions? You want to?
I have a comment.
Yeah.
I see this coming in handy. Not so much for, well, some of the assessments that we've done that I've helped with, the person is trying to get bullets to help get the equipment that he needs that he hasn't been able to get previously from the people that have the money. So using this to where he can say, you know, this is black and white, this is how it's going to save you money as the company financer and get his equipment. So I see this as good bullets in the if we can put this in somehow into our report itself to help that person get the funding he's looking for from somebody higher up. Does that make any sense?
It does make sense, and in a lot of ways, it would depend on the financial sophistication of the decision maker. You know, if you're dealing with a well-established corporation with a CFO who has a sophisticated background in financial analysis, this is going to be sort of second nature to that person. Okay? If you're dealing with someone who's not as knowledgeable in financial analysis, then you're going to have to sort of walk them through what all this means. And that's going to take a little more elbow grease, I think. But it does, in my view, help highlight the limitations of the simpler metrics like simple payback period. If that's what a decision maker is hanging their hat on.
So I'll jump in and ask a question to Kevin on, do you have suggestions on how we communicate with our clients to get information so we know how to present this information back to them? When we sit down with our clients, should we be saying, hey, so we're going to do a cost benefit analysis for you, a preliminary one based on this energy assessment. How do you want to see that? Do you want to see it as simple payback, as net present value, as internal rate of return, as an investment ratio? Like, should we be asking that question? How have you navigated that? What would be your recommendation to us?
Well, I think the way to frame that might be to ask, what financial information do you need to input into your decision algorithm?
Okay.
And again, suggesting some of those metrics might make that easier for them to decide, because quite frankly, some of them may not know.
And then if we're going to do something like this, then we need to know what they use as their discount rate, or maybe even more information. Like
Maybe even more
financing.
information. You
Yeah.
might want to ask them, what's your net margin?
Mhm.
You know, and if they're honest brokers in terms of
Right.
evaluating these investments, they're fine with sharing that information,
Okay.
even if they're closely held. Or a publicly traded company, that's public knowledge.
Okay.
Right.
Right. Okay.
I mean, you can go look and see what General Motors' net margin is on any number of sources. It'd be in their annual report. Or 5 Points Restaurant on Broadway. They may not want to. They're not going to be as ready, perhaps, to share that information if they even have
That's such a figure, right?
have that number. So then you can go to the website that's in the PowerPoint, the Stern Business Study, that they keep updated, by the way. And you can say, well, for a restaurant diner, we'll just use that number. That's the beauty of that kind of thing. Okay. And again, I don't present this as a strong proposal to change how you're presenting information now in your reporting to clients, but it's worth considering. It's worth going through this exercise, because if you're already somewhat skilled with using Excel, and most of us all are nowadays, this is not extremely difficult to do. The difficulty is still in estimating the cost.
Yeah.
That's the difficulty. This is just a simple way to portray that. And again, just simply showing that energy savings tracking with inflation in itself may sway a reluctant client to look beyond that myopic view of the first year.
Yeah.
Okay.
So I have a question. So, if we look at this and you look at your cash inflows, energy savings, maintenance savings, those are not cash inflows. They are avoided costs from some model showing that you would have spent that money.
That's true. That is true.
So what do we need? Is there any watch out when really a lot of this is avoided costs based on some projections? They're not absolute values. For example, I'll just throw this out there. The state had the Utility Savings Initiative, and they had a big goal for 13 years of that program. And in the end, they avoided, $1.1 billion. There was no time value of money in any of that calculation, and those were all avoided costs. So a lot of people said, well, that's not real money. Those aren't absolute costs. That's just avoided. So what case do you make on that when people say, tell me absolute? These are all hypothetical.
Well, I think there's two things. One, yes, these are estimates.
And I'm not talking about being an estimate.
No.
But you know what I'm getting.
It is
Right.
a projection, an estimate, a reasonable best guess of these savings. And these savings, yes, they're avoided costs, but these are avoided costs that you're putting in your pocket. It really is real dollars. If you would spend $10,000 a year on utility bills, then you do this project and you're only spending $6,000 a year in utility bills. That's real money. That's not monopoly money. Okay? That's real money. Now you have made an investment, but you also own the asset. Okay? When you sell the building, for example, a buyer will look at the lighting. That will actually make the building more valuable.
Mm-hmm.
So you can talk in all those terms, but the idea that avoided costs are not real money is misguided in my opinion.
Well, that's good. Well, I mean, I think that we want to have that vocabulary to make that case one way or the other, because we could have the devil's advocate saying that's just an avoided cost based on a projection, from an absolute, so they just might have a different perspective on that.
I understand, yeah.
So like a political appointee passing the state budget says, that's not real money. That's that perspective of it. So it's just something to deal with.
I understand. I understand where you're coming from.
Yeah.
And,
Yes.
and again, I would argue that
Yes.
those are real dollars.
Those are real dollars
that
to operate.
that you can take and reinvest in your business or carry home as profit. Those are real dollars. Now, again, you have made an investment, but make an investment when you occupy the building. You make an investment, you pay your employees. You make an investment when you buy supplies, or you put a new piece of production machine, buy a forklift for the warehouse. You do that with the idea that that's going to perhaps avoid costs.
Mm-hmm.
For example, you have a 20-year-old forklift. You say, I'm going to invest in a new forklift because I'm spending $200 a month just in messing with it.
Or you're investing, in many cases, just in the item because you're going to increase your revenue.
Exactly.
Or maintain revenue, not necessarily. So I have another question for you. So this whole presentation has really been around businesses and, thinking about their net margin. So how does this change if we're dealing with a nonprofit, if we're doing work, with Helpmate locally, or a church, or some other nonprofit? What's our vocabulary change, or how does any of this change if we're working with a nonprofit?
Well, I think the only thing that becomes irrelevant is the equivalent revenue calculation. Everything else there,
Mm-hmm.
it's finance.
Is it
Whether it's the only thing that even considers profit is that equivalent revenue calculation.
Is a nonprofit going to have a discount rate that they utilize?
Well, sure.
They will. Okay.
Sure.
Yeah. So
If
they'll
they
still.
don't, they should.
They should. Okay. So they still may have that concept in
Because
their financial
a
plan.
nonprofit may have things like endowments that they use to invest and then take returns from that endowment to fund operations or projects or whatever. This is just another investment. So the cash flow language doesn't change. Okay.
would the reinvestment, like scroll back up to your inputs there, you know, you didn't address some things like that reinvestment.
I did not,
Is
and
that more important for a nonprofit or not necessarily?
not necessarily, not necessarily. I mean, that's something you can discuss with them. Absolutely. But I would say, but in general terms, the only thing that doesn't apply is net margin, because they don't have it. They don't have it. Yeah, and the other thing, and particularly dealing with churches, I'm active in a church, I'm active on our green team or whatever
Right.
that body might be called within your faith community. I did my master's thesis on sustainability within faith communities. So I'm very familiar with that world as well.
Sure.
You know, there are ways to frame the larger discussion in the language of things like creation care and
Right.
those kinds of theological
Values, yeah.
values. Exactly. So that's another important point, regardless of who you're dealing with,
Mm-hmm.
is appealing to value. And so, you know, and not all businesses are created equal. No. So the business owner who's a hard bottom line guy, say, look, you need to increase your revenue by X number of dollars to see the same kind of contribution to the bottom line. You know, that's one conversation. If you're talking with the owner of a vegan restaurant who's very involved in whatever local environmental organization there is, you might frame it in terms. You might also do a CO2 reduction or carbon reduction, carbon accounting terms as well, and those tools are readily available.
Right.
Easy to plug in.
Yeah, and like in our analysis, like in our workbook and so forth, we do that calculate, so we show them
Right.
carbon.
Right. But that might be a larger focus of the conversation. When you're talking about a business or nonprofit or whatever, making a substantial financial investment. That substantial financial investment part puts a lot of people off right off the bat.
So I have another question. So I feel like, you know, some small business owners, if they're not looking at like net present value, or they're more comfortable with simple payback period, is there yet another like beefed up version of a simple payback period that you can account for the 10-year project cycle, but present it in terms of this months, or like, am I missing a term that might be out there that you can, you know, maybe it's the saving to investment ratio that is actually taking into account those maintenance savings at different years.
Right.
You see what I'm saying? Like something that's a little bit more beefed up, because those are tangibles. But see, ROI and simple payback, they didn't change because that's based on year one, right?
That's right.
But if we know that, you know, these other outlays are going to be out there, is there any other term that we can use that's not, say, net present value, that's like, that can account for that, but it's in the simple term for someone that may not be as comfortable looking at net present value?
I think.
I mean, is it the inverse of the savings investment ratio?
Well, the inverse of the savings, the inverse of the,
That didn't make sense for me either on what that means.
well,
But anyway.
that savings investment ratio calculation is the present value of the inflows over the 10 years, divided by the outflow.
Right, so that's kind of what I'm getting at, but putting that in terms of months. Is there some other presentation that you've ever seen, heard about,
No, I think,
or years?
I think quite frankly, or one area to focus on would be the inflation adjusted energy savings over that period, and just say, if you wanted to take that row out and put that on a graph, say this is what your energy savings will look like over time.
Yeah, that might be.
That might be
powerful.
as powerful as anything. And the other thing to overcome, again, and I keep making this point, people think they're throwing away money on lighting. And no, they're making an investment. They own the asset. It's just like if they were to put a new sign out in front of the business. And quite frankly, in financial terms, the benefits putting the lighting inside are easier to quantify than the financial benefits of a new sign out on the highway. Okay. Or investing in a billboard. It's really hard to quantify increase in business based on some advertising, right? Well, it is for me as an engineer. I'm not an advertising person.
But I think that's where your equivalent revenue is perfect. I put a sign out, I bring in $4 million more, or I invest in this project for $50,000 and save the savings that would be equivalent to selling $4 million more.
Yeah.
In that way, you can really sell it on a revenue basis, which is, I think, how so many of our other investments are made, based on revenue and not because things don't save money. Most investments aren't saving money, they're bringing in revenue. Right. So that's a nice comparison then to say, well, do you want to beef up your marketing, or do you want to invest in lighting or a new chiller or whatever that is.
Exactly.
So that's interesting. So other questions for Kevin? Anybody there's a little raise your hand thing, or you can just unmute and jump in. I've muted somebody on the phone. Maybe they're gone. Okay, sorry. We had a little feedback on the phone.
I'm just going to keep the spreadsheet up here while we close out any other discussion or questions. I hope this has been helpful in the way you think about the financial side of this whole business, because we engineers are sometimes real excited about technicals. This is kind of drudgery.
Well, so any questions out there? I do have a couple other topics related that we'd love to get your input on, and Adrian, I'll pull you in a little bit, because Adrian's been doing a lot of financial work lately and presenting information in kind of, different ways that we normally present it. And so one of these is a question about making a recommendation, say, for say it's a more efficient motor. And so we know, say it's a ultra efficient motor, because super efficient are the standard now, right? So, right. So it's an ultra efficient motor, and we know, but we're not saying for somebody to replace their current motor. We're just saying at the time your motor burns out, or you have to replace it, and you're not going to rewind it, you should get this ultra efficient motor. It costs a little bit more, but it's just much more efficient. So when we do our payback analysis or cost benefit analysis, we're doing it on the delta, the difference between the the standard motor cost or the one we would have bought versus this ultra efficient motor cost, that delta, and then say, compare the savings to that delta because we were going to invest in a new motor anyway because it burned out.
Right.
So,
Well, in terms of this analysis, in the single investment
mhm.
D12, that cost you would put in would be the premium.
Right. Okay, the premium.
The premium cost.
So we're going to
Not
call
the
that the
full
premium.
cost.
The premium cost.
Or
Okay.
whatever term you use.
Right. Oh, yes, right. In
The
this
delta,
particular
whatever
case.
that is.
Yeah.
Yeah. So the analysis is based on that cost delta.
Yeah. So in some cases, like for instance, I'm just going to pick on Adrian again, because he's working on this report and probably pulling your hair out on it. But he's actually presented some where you have a deferred maintenance issue, like a chiller, and then you're going to get a more efficient chiller, and maybe it's the same cost. It was just how you expected, and so the investment cost we're showing in our table is zero because there's this assumption it was going to be replaced anyway.
Right.
So, when you present that back to someone, they may accept that, or in this case, somebody says, well, I get what you're doing, but I still need to know the cost. But I just didn't know if you had any insights to share on the presentation of an item that was deferred maintenance and needed to be replaced, or this premium, or just any other feedback for us on how we're presenting information there. Because it becomes an issue, on how we do that.
I understand. And, it's hard to, I think, explain to some folks the idea that this better thing is going to cost the same as this worse thing. And you've got to do at least the worst thing, right? So
Right.
if
Yeah.
the difference between these is zero,
Mm-hmm. Right.
that does.
Yeah.
So maybe the answer is you can take this, you can actually modify this spreadsheet if you want. You could say, option A cost, option B cost. Then you could actually
Show the savings.
show the savings between option A and option
we
B,
compare.
and
Yeah.
compare them that way. But you do the same thing by putting the net
Right.
cost, the premium cost,
Right.
in the investment block. That's the same analysis, basically.
We have done that in some cases. Like we did a lot of work with, say, AV Tech, and they had deferred maintenance items. So we were really showing them the life cycle savings of a standard, say, one-for-one replacement of a chiller with a, high efficiency chiller, and then showing what that life cycle savings would be of that more efficient choice. So we did nothing about really the capital investment or anything else because we assumed those things were going to happen, but we showed that kind of life cycle savings based on the efficiency. And then, let the finance people throw those numbers out there when they were, pitching their projects to, city council or whoever was approving the budget by saying, hey, we're actually going to be saving, $200,000 over the term of the life of this project by, taking this choice now and doing it. So it was just a different way of putting some numbers out there and not getting caught into all the pricing.
Well, and the other thing is, again, terminology might suggest that you put, instead of financial analysis of energy improvements at the top of your spreadsheet, put life cycle cost analysis. Because that's essentially what we've done. assume a life cycle of 10 years. We're accounting for cash flows over that 10-year period. That's is a life cycle cost now, right?
Right.
So that terminology might be more attractive than net present value, or less scary, or whatever is appropriate there.
Yeah.
Again, a lot of it is knowing the client, knowing the language, attitudes of the client,
Right.
and framing your pitch, as it were,
Right.
to appeal to those values. And all this started engineering school. Whoever thought we would be psychologists and sociologists and salesmen?
Very true. All right. Okay. Any other questions for Kevin? Here's your chance. Pick his brain.
Well, I was going to wait till you were finished, because I don't know how much general interest there would be. But from your first lecture, Kevin, I looked into that Design Lights
Right.
website because I'm really interested in. I live in a retirement community, and certain places, in fact, most places, the lighting is terrible, and we're going to have to come to grips with that when it's time to replace those droppers and fixtures. And I was wondering if there is something in there. In that website, I looked under the SSL, the solid state lighting, and then some of the other options to argue in favor of something that is really efficient, but may not be in the decorating trend of that particular time in decorating cycles. And some fixtures have these little fluted lamps that look like teardrops and all this, and some of the executives favor this really flourishing looking thing in place of a really efficient LED. Might this kind of an analysis comparing the energy savings versus expected replacement times bring forth a really solid argument in terms of what makes sense and what the unnecessary expenditure?
Oh, sure. Like you could use this directly for that, well, I'll just say, like, the good news is a lot of those fancy bulbs, they're all available in LED now, and they actually even look better in LED. Like, things like Edison lamps and things like that are completely,
Whatever
available.
now the trendy decorator stuff is, it is indeed available
In LED.
in LED,
Yeah.
and of course SSL, solid state lighting, is
LED.
LED. Another term, fancy term for LED.
So, like, candelabras and things like that, you could keep your same chandelier and just put LED fixtures in there. They can be dimmable, they can do everything, and then show the replacement, the life cycle, all those, because the maintenance for those things is,
Oh, yeah.
like those little incandescent bulbs burn out, 1,000 hours, 500 hours, and now you've got a 15,000 hour LED or something. So, like, looking at it there really would make the case, and you don't have to give up the aesthetic today.
And there are two really different, distinct qualified product lists for lighting. Design Lights is one, and that really is fixtures. And then Energy Star is for lamps, for bulbs. So your screw-in bulbs are likely going to be down on
Yeah, I did. That one.
Yeah. Although, the extent to which some of the more esoteric bulbs, you have to look and see.
Yeah.
But
yeah, we can help you all do that. Like we've got several folks that would love to do that analysis for you and show you the options you have, and so I think that's the exciting part, is that you don't really have to give up the aesthetics and you can go to LEDs. Now you may have a mix of things, and we've just replaced. We had more architectural fixtures in here than these panels, but we can now see in here because we couldn't do that before. So I'll take it.
Exactly. That's what I'm driving at.
lots to be said.
Right, but they're not horrible. But in fact, there's 4 different color temperatures, so that's interesting. So
But
we wanted to get in between the two, obviously.
yeah.
So, but well, hey, so we're at 11:38. I want to ask the folks online if they've had any last questions. Dick's having to leave.
Terry,
Russ had to leave.
I left
Go ahead, Robert.
I've lost my hand raising ability for some reason, but I wanted to ask about future cost, I put my question in the chat about, lower cost of natural gas not accounting for future cost of removing CO2 from the combustion.
So please discuss artificial low present costs of natural gas for heating, less the future costs of removing carbon from the atmosphere. So you're kind of looking at how do some of these marginal costs get accounted for? Is that kind of the question?
Yes.
Okay.
That's a good question, and I would have to do some serious research into not only natural gas pricing, but the more difficult accounting exercise that, quite frankly, is sort of the elephant in the room in all of these analyses, is that we really don't account for environmental effects. I mean, that's the heart of a lot of decision making that goes ignored in lots of ways.
Yeah.
And the examples of that are legion, with things like the environmental cost of coal mining, how we don't take that into account. Those social costs.
Yeah.
For lack of a better term, that gets pretty complicated in terms of, say, your question implies, or I infer from your question, and correct me if my inference is wrong, but that you're considering the implications of, say, replacing a gas furnace with an electric heat pump, or a
That's correct.
natural gas water heater with an electric heat pump. I would think that even not accounting for that larger environmental cost item, a basic cost analysis using this tool would probably come out in favor of the electric heat pump or a heat pump water heater over a natural gas water heater. I haven't done that analysis. I'm just speculating.
So I'll throw out something. I think the utilities right now in their kind of, resource planning, they're putting in a cost of carbon into their economics. And so, yes, I mean, that doesn't account for the other social costs, but there is some perspective to say that, you know, if there's a carbon tax or what this carbon piece is, that it's out there. And so I don't know if, you know, and there's some numbers that they use, you know, in the planning process. I don't know if we were to use a number like that for our kind of end user component to try to account for that, how that would skew the process. But that might be one way. I think that folks are putting in, accounting for the marginal costs that aren't normally, those environmental costs are normally accounted for. There are some numbers floating out for carbon, because we have other, you know, societies that have a carbon tax and there's a carbon value out there, or the value of not spending it. So there is some economics attached to that. So that might be one way to
Maybe.
throw that in there
And if,
start.
And if the utilities are including that, then maybe that, at least some of that's already accounted for in that utility rate and in the utility
Yeah.
savings.
Maybe it's already, and that's why our rates are going up 5% a year. I'm just kidding.
But
yeah,
it gets real complicated. And I don't know that there's
yeah,
a precise answer.
Yeah.
It's, you know, but it's like in lots of things we do in engineering, we state our assumptions. As long as we state our assumptions clearly, we can debate the assumption. You know, in the end, all this, you know, even the cost savings from replacing the lighting is assuming that operating hours are going to be the same and occupancy is going to be the same. We're making lots of assumptions
sure.
to even come down with what we have here.
Yeah.
That we state with some caveats is reliable, right?
Yeah.
So
it's changing, but I really feel like that, you know, a value on carbon is one step closer to the alignment of making economic choices because of values, whether that's the faith community making a value or it's the corporation putting a value on their environmental footprint or something like that. So I think it's one step closer because really,
right.
you know, you don't really get marginalized dollar values for some sort of social impact. I mean, you just never see that in these calculations.
We're one step step closer to the apocalypse.
One step, right. So,
well, that was a lot of talking around a very good question.
Yeah, no, that's a good point, Robert. And I think it, you know, it is interesting on just how we're going to get there. And, you know, what's really, I guess, interesting for me now, because, and we even have a grant that's going to help this, you know, help us, you know, with so many larger companies and publicly traded companies making very aggressive goals to say they're going to be carbon neutral, including Duke, well, I guess maybe our state said that to the legislature, but you know, there's a lot of entities saying they're going to be carbon neutral by 2050, by 2030. We've worked with a lot, even localities saying that. It really begins to push this question of how do people make those economic decisions? And these numbers are going to be really important. And I think, you know, this concept of, well, we're not going to do anything if the simple payback period is in 3 years. Well, that's not going to work anymore if we're really going to make those choices. And you know, Ron's up there. He did some evaluations with Pilgrim's Pride. They've got a 2030 carbon neutrality goal. You know, one of their plans is, well, how do we develop a solar farm? Could we develop anaerobic digestion at our lagoons? How much efficiency do we do in our plant? Do we just go buy renewable energy credits? How do we get there? And I think, you know, some corporations are giving some guidance at the corporate level coming down to the site, but a lot of the folks we work with are out there saying, what do I do? Where do I make the investment? What are my projects? And, you know, it's an interesting thing. And a lot of that's, it's going to come to call because the clock is ticking and, you know, and it's hard to get there.
And that brings up another point, and that is the value of a net present value analysis in comparing two investments. An entity that has a fixed amount of capital to invest may be looking at 5 or 6 different projects. And so this would be an important piece in choosing which project to pursue.
Right.
So, that's another value of this kind of analysis. Now, you could do the same with simple payback period. I think you get a more rigorous
Yeah, for sure.
comparison.
Right. Especially since,
Using this kind of analysis.
yeah, because the life cycle component is even more important, I think, for those.
Yeah. And
So.
if you're using the same inflation rate,
Mhm.
the same discount rate, the same assumptions, then it becomes a very useful comparison.
Right. Okay. Other questions? Thank you for the folks that have hung out to hear this
Thank you, guys.
extra discussion. So, yeah, thank you to Kevin. Russ had to go. He wanted to thank Kevin and Dee, and the same with Dick. But this has been really super informative, and we're going to post all this up on our SharePoint site, including the recording. The recording. Yeah, the recording, because we are recording, and the Excel spreadsheet too. So you're welcome to. I guess nothing's locked in that.
No,
we can modify if we need it. So yeah. So I encourage everybody to be thinking about that. We in our standard reports in our own workbook we use. We're kind of fixed on the simple payback methodology, but we can build this in. We could create. This would be no problem really to build in more economic calculations into our spreadsheet if people want to show numbers in a different way, or talk about that equivalent. I can't get it. Equivalent revenue, yeah, the equivalent, because I think that's pretty powerful. So anyway, all right. Well, thank you, Kevin.
Thank you.
I appreciate it. Good to see everyone, and yeah. So
Have a great Thanksgiving.
yeah. Till next time. Thanks so much, everyone. All right. Very good. Well, you made it. Good. Good discussion. All right.
I hope that was.
You're gonna come.